So far, all that we have been doing is look at linear programming, where the numbers can be decimals. Our interest is now to look at integer programming. What is an integer? What is an integer? Who has an idea? Ben?
I think integer is a positive whole number.
Well, technically, that is not integer. Technically, I spoke generally.
Okay, so generally, integer is a whole number. It's a real whole number.
Positive or negative?
Yes, positive or negative.
That's what I wanted it to say. Because if you say positive, it throws it away.
Okay.
But if you say that in a linear programming parlance, it is a positive whole number, yes, then that one is good. Today we want to look at integers. Because there are certain things that are not decimals, they are whole numbers, like the number of cars produced. It can never be 400.18 cars. The number of buildings constructed. You cannot have 2.78 buildings. So sometimes people are tempted to round them. But if you round them off, you cause problem. For example, suppose somebody's income is 100 billion. Or it is actually 99.1 million. 99.1 billion. You round it up to what? 91.1 billion, 99.1 billion. If you were rounding it, you round it to what? Ben?
99 billion.
99 billion. So how much have you thrown away? Ben?
So you've thrown away 100 million.
Exactly. If I give you that 100 million, is that small boy?
No.
That is why you cannot round things up. You can't. Okay. You can't round things up. And therefore, you have to introduce an integer constraint or an integrality constraint. That integrality constraint can be an integer and then a binary, a positive integer or a binary. Now, what is the difference between binary constraints or binary constraint and then integer constraint? What is the difference between binary and integer? In the context of where we are here today, Mayor.
Sir, please, binary takes the form of 0 and 1, whilst integers take any whole number, including 0 and 1.
Excellent. 2 marks for you. Ben, 2 marks for you. Mayor, 2 marks for you.
Thank
so
you.
Let's move on. Class rep, please take note of this seriously. So we are going to look at integrality constraints, and we are going to see how all of these things match up together. Now, there are 3 types of integer programming models. There are 3 of them. The first is pure integers. So that one, all the decision variables are integers, all of them. Now, let me see if I can quickly take you back to a model that was done. It wasn't done, but it was recorded for you. But it wasn't done for you. Look at the final value, also known as the decision variable. TV commercials, radio commercial, newspaper ad. Do the final values make sense or not? And why? The final values, do they make sense or not? And why? Emmanuel.
Doc, they don't make sense because Yeah, talking about number of commercials, and you are saying 1.8. 1 is okay, but the 0.8, how are you going to treat it unless you round it up? So that's why it don't make sense.
What else? Still on you. What else? Still on you. Okay, Mayor.
So the first and the last one don't make sense, but the middle one makes sense because it gives us the whole number. While the first and then the last one, 1.8, and then the 3.1 gives us decimals.
Okay. Why don't they make sense?
Because you can't have a point like a commercial that has maybe a point.
Good. That's how it's supposed to be. Okay. It shouldn't be like that. So we are going to solve that by making sure that all the decision variables are integers. And you will also have a situation where they are binary and the situation where it is a mixture of all of them, both integers, both binary, as well as even decimals, non-negative. So let's start by looking at total. And to do that, I want us to look at this storyline. Agbala. Somebody should read this for us. Somebody should read. Who can read? Yasin.
Agbala, owner of a machine shop, is planning to expand by purchasing some new machine presses and lathes. Each press purchase will increase profits by 100 Ghana cedi per day, and each lathe will increase profits by 150 cedis daily. The number of machines Agbala can purchase is limited by the cost of machines and the available floor space in the shop. The machine purchase prices and space requirements are as follows. So for press, so the requirements are there. Agbala has a budget of 40,000 cedis for purchasing machines and 200 square feet of available floor space. Agbala wants to know how many of each type of machine to buy to maximize the daily increase in profit. Formulate the integrality problem.
The teacher programming problem.
Oh,
All right.
integrality.
So is this a maximization or minimization? Who will tell us? Is it a maximization or a minimization? Yasin.
This is a maximization problem.
Okay. Now, the items that you are dealing with, the decision variables, what are the names for them? The decision variables here, what are the names for them? Stanley.
Yeah, the latest and the presses.
Okay. How will you formulate the decision variables? How would you formulate the decision variables?
Should I continue?
Yes.
Okay, so you see, if you are using the x1, x2, then you're going to say then x1, comma with x2 will be the number of presses, comma, and number of letters.
Number of presses and number of lathes. Good. So if you are to apply constraint to them, what constraint will you apply to the press and lathes? What constraint, apart from the non-negativity constraint, which of these constraints will be applied and why? That's it.
There is a budget constraint because
No. I'm talking about the press and lathes. What will you call them? What will you say? What limitation will you give to them?
I don't understand the question.
Don't worry, hold on. Somebody will understand and show you. Pearl.
Doc, I want to try. So it will be Z max equals to.
I want you to tell me, based on what we've already learned, what constraint or what limitation will you just give the fact that it is non-negative? What else will you say? Matthew.
Doc, please, the floor space.
No. Leo.
So both x1 and x2 should be greater than or equal to 0.
It is greater than or equal to 0. That is the non-negativity. What else can you say about them? Cloud.
So x1 and x2 should be integer.
That's it. 2 marks. So x1 and x2 are supposed to be integer because they cannot be decimals. It's like talking about nika, and you want it to be decimals. That's the most important thing. The rest is the formulation is very simple, and everybody here should be able to formulate. So what will be the objective function? What will be the objective function? And here, Badake.
Yes, Doc. The objective function will be Z max equal 100x1 plus 150x2.
What is the next constraint? After the objective function, what is the constraint?
The constraints will be 15. Yeah, 15x1 plus 30x2. No, 8,000x2 is less or equal to 40,000.
Okay, that's wrong. Let's go to cloud. Cloud.
Yes, sir. It will be 15x1 plus 30x2 less than or equal to 200.
Continue.
And 8,000x1 plus 4,000x2 less than or equal to 40,000.
Very good. 1 mark. So that is how you got to do the formulation. This is it. And then after that, add your non-negativity constraint as well as the integrality constraint. Now, the non-negativity constraint and integrality can both be written like this. In this case, x1 and x2, both of them are integers, so that's how you write it. And if x1 was not and x2 is, the way you write it is also different. This is what is known as the total integer, because if you look at the decision variables, both of them are integers. Now, let's go to the next one, which is a binary. These are not the most important one I'm planning on teaching you today.
Doc, please, I have a question.
Yeah, go ahead.
I remember, I think when we had a physical class, you mentioned that every constraint is like an individual constraint. So I want to know if it's okay to put the integer constraint on the line below the non-negativity.
Oh, but the comma shows that it's different.
Okay.
See, the others don't have comma.
Yes.
Yeah.
Thank you.
But you can still put it below. What is the difference between pure integer constraint and binary constraint? Well, the best way to explain binary constraint is to give an example. Legon Council must decide which of the 4 recreational facilities to build. They've got to choose among pool, tennis, athletic field, or gymnasium so as to maximize daily usage. The expected usage, the cost, the land, everything is shown here. So as an example, if they decide to build swimming pool, this will reach 300 people a day. In other words, 300 people participate in the swimming pool. But that will cost $35,000. And it will require a land of 4 acres. If it is a gymnasium, it will require 150 people to use it a day. 90,000 is the cost, and the land requirement is 3 acres. Now, Legon Council has 120,000 budget and 12 acres of land there. Because swimming pool and table tennis must be built on the same piece of land, only one can be built. Legon Council want to know which facility to construct to maximize expected daily usage. Is it a minimization or a maximization problem? Minimization or maximization? Sally?
Say maximization.
Good. What are we maximizing?
The expected daily usage by the residents.
Very good. 2 marks for that. Class rep, take note of all this. Now, what tells us that these things are binary? What tells us that the decision variables are binary? Benjamin.
Yeah. So per the question, we have to choose from 2 options. That is the pool and the tennis. So we have 2 variables we are working with.
What are they?
The tennis and the pool.
Tennis and school. That's wrong. Let's go to Yasin.
It's non-binary because you have to choose between 2 options, and if you choose to do a pool, it means you can't have the other. I think the other is tennis also. And if you decide to choose tennis, it means you can't have the pool. So it's between 1 and 0. That's why it's non-binary.
What is non-binary?
Like when it's a base that uses just 2 numbers, which is 1 and 0.
So I'm asking, what did you say is not binary? What is not binary?
Like the fact that you have to choose either a pool alone or the tennis center alone. You can't have both.
And that means that it's not binary.
No, it's binary. Sorry.
You just
It's
said twice
binary.
that it's not binary.
Sorry, it's binary.
You're confusing everybody. So let's start again. Calvin, what do you want to say?
Look, I want to try. So in the question, you have things that you have to build, facility that you have to build, but there's a constraint of how much land that is available. And
it's a constraint to indicate that the decision variables are binary or not. You cannot use a constraint.
Yeah, okay. So from reading the question, there was a part that said,
I know the part, and I'm saying that you can't use that part to say why or not is binary.
Okay. That's what I was trying. So
Carl.
Try.
Yes, sir. To say it's binary is to say that you can have one in your decision. So we have 4 recreational facilities. So we have pool, tennis center, athletic field, and gymnasium. Now they're supposed to pick only one that they can build. That's what makes it binary.
Yes. Guide your thoughts towards this binary. Give me a word in the whole sentence.
Doc, please, can I speak?
No,
I haven't called you.
The word is to.
I haven't called you to. Yes, Emmanuel.
Doc, the word is to.
Choose. Is that what you said?
No, to.
Tool.
Or
Where is that?
two. The number 2.
Number 2. No. No, not at all. Kel,
The word is choose.
where is that?
The word is choose because you have to make a decision between the 4.
Other word.
Excuse me.
What other word?
What other word?
Yeah.
You have to choose among. Decide. There's a decide
Right,
up
too
there.
much. Too much. So those words are the key guidance to know that this is truly binary situation. Choose and decide. Choose and decide. Now, if you were to write the objective function, who can indicate how to write it? Who will teach us how to write the objective function? Augustine. Yasin.
Sorry, please, that was the wrong hand.
Dr. Stephen. Stanley.
The objective function for this one. So the maximum z will be equal to 300x1 plus 90x2 plus 400x3 plus 150x4.
That's a decision. The objective function for what?
For the recreation facility.
Yeah, I heard you say for x1. Is that what you said?
Yeah, I said zx will be equal to 300x1.
What is zx?
The maximization of this. Z equal to, I said z equal to, sorry.
It's not z equal to, it's z max.
Z max equal, okay.
Equals to each one of these, right?
Yes.
What is attached to each of them?
Say I didn't get your question. Attached to plus, it will be x1, x2,
It's
x3.
attached to each of these.
Yes.
What is attached? Benjamin.
People per day.
What is attached to them when you're formulating? Mayor.
So the decision variables.
The decision variable, that's what is attached to them. Very good. 1 mark for you, Mayor. You're thinking, you are consistently thinking. Now, so you're going to get 300x1 all the way up to 150x4. Okay. So this will be the decision or the objective function. What will be the first constraint? Who can walk us through the first constraint? Karen. Karen.
Sir, please, the constraints for the budget will be subject to 35,000 x1 plus 10,000 x2 plus 25,000 x3 plus 90,000 x4 less than or equal to 120,000.
Okay, so Karen, next time, respond earlier. I don't know why you weren't responding earlier.
Sorry, my mic was muted.
Yeah, it's muted. But once you raise your hand, you know I can call you, right?
Yes, sir.
Once you raise your hand, I can call you. So your hand must be on the same section that made you raise it.
Yes, sir.
Okay. So that is 1 mark. What other constraint do you have to formulate? So this is a formulated constraint that Karen did. And she said this is less than or equal to $120, 120,000. What other constraint are executable?
4x1 plus 2x2 plus 7x3 plus 3x4 less or equal to 12.
Very good. You also have 1 mark for that. So all of these formulations that your colleagues are talking about, guys, you should be able to know how to formulate them. We are not done yet. In fact, what would be the decision variables? I didn't talk about that. What would be the decision variable? How will you write the decision variable? Jennifer.
So the decision variables will be, let x1 be equal to the construction of the swimming pool.
That is a lie. You are copying from the notes.
No, I'm not copying from the notes.
You are. You are.
I'm not.
Because what you said is wrong. I want you to use your own words to say this, because other than that, you wouldn't ordinarily have used the word construction.
It was stated in the question.
That's why you're using it.
Yes, please.
That makes it wrong still.
Come again.
I'm saying that makes it wrong. Because he didn't say that. Look at it. Where is it that
No,
he
please
said?
let me try.
No, I want to ask her. Where did he say that? In the question. Yeah. Are you there?
Yes, and it says LC wants to know which facility to construct in order to maximize the expected daily usage by the residents. So that's why I picked my formulation from.
Yes. But you wouldn't have made it a noun, would you? Because you've got to bring the unit of measurement. But you didn't bring the unit of measurement. So when you say what you said, how will you bring the unit of measurement? What is the unit of measurement?
Acres.
No, it's not acres. Construction is not measured in acres. That's why there's a better way to say the decision variable. Who can correct it? Who can say the better thing? I hear Beteke. I hear Beteke. Are you with that?
Yes. Doc, please. I will say, because it is construction, I will say facility.
No.
Instead of saying acres of land.
No. Not at all. So the decision variable will be whether or not to construct a swimming pool, whether or not to construct table tennis, whether or not to construct athletic field, whether or not to construct. So you got to say that let X1 be whether or not, because we already said that this is binary, right? Whether or not to construct a swimming pool. And the rest will follow equally like that. This is how you got to indicate the decision variable. Guys, it's important you're understanding this. If you don't understand, please ask. And remember, the binary is when something is equal to 1, presence, or 0, absence. So binary, the 1 here refers to when the thing is there, and the 0 is when the thing is not there. If you don't understand, ask. If you don't understand, ask. These are what you guys do when you're at home. You don't get so much concentrated, and then you say that the course is hard. It's because you are not participating and asking the questions. Yeah, Augustine.
Okay, so I need to get some clarity here. So the binary and the mutual exclusivity, how are they linked or related so that in formulating our objective function, whether or not to construct, or so that can help us understand the objective function.
Yes, same. Two events are mutually exclusive. One cannot happen.
Yeah.
It means they can't happen at the same time. But these are not events. These are not separate events. The construction of a swimming pool and that of a table tennis are not separate events. It's a choice event. It's not even an event. It's an action. It's not because an event will have a lot of things inside it. So when you go to swimming pool, you are deciding whether to build swimming pool or not, forgetting about all the others. When you get to table tennis, your goal is to decide whether or not to build table tennis or not. When you get to athletic field, you make a decision solely based on athletic field, not in conjunction with the others, whether or not to build athletic field. And when you get to the gymnasium, you are making a statement about gymnasium alone, regarding whether or not to build it. So each of them will become binary in their nature. Yes, Stanley.
Yes, Doc, I wanted to find out what if I use the word either or without also qualified?
Make the sentence instead of the halfway you've spoken.
So like you were saying, whether or not, and I say either to construct
sentence altogether. I want to say, Doc, if it is either or not for what? In what? Put a sentence.
In the construction. Like to complete, I'm just
the last time, write the question well. Okay. You want to say that X1, let X1 be what? Write a sentence. So that I know what you're talking about. Because that's what you do to define the discipline. So
okay, so if I say let X1 be either to let S1 be the construction of the pool, or either the table tennis construction.
You can
tennis center.
You can never say that X1 is the construction of a swimming pool or table tennis. Never. Because the construction of a table tennis has nothing to do with a swimming pool. You can't use what they have said here, this other constraints, which we shall come to. You can't use that one to define. Okay? Where he says that because swimming pool and table tennis must be built on the same piece of land, only one can be built. You can't use that to define the objective function, the decision variables. So when you take swimming pool, it is either you build it or you don't build it. You go on to the other. Even if the others are not there, you got to make a decision whether to build or not. Swimming pool alone. Okay. So that is how you define your objective function. This one that I gave in the slide is not is deliberately to be incomplete. That is why when you actually use those phrases, I was wondering whether you took it from here. Okay, so now you've defined your objective function, and now you've also defined, have we defined a constraint? Have we defined a constraint?
Yes, please, we have.
So let's come to this part of the question. Because swimming pool and table tennis must be built on the same piece of land, only one can be built. Now, the word must be built is what symbol? If you are going to build anything at all here, any of the 4 recreational facilities, if you are going to build any one at all, the word build here is giving what value? Belinda?
The 1.
Okay. So what does the must be built? What does it contain? Belinda?
So I don't understand. What does it contain?
Yeah, what symbol does it contain?
1.
Yeah, the 1 is a build. Let's go to.
Equal to.
All right. Emanuela?
Equal to.
Equal to. So how will you write must be built? How will you write must be built? Mayor?
It should be less than or equal to.
No, that's wrong. How will you write must be built? I have it okay.
No, please, equal to 1.
Exactly. That's too much. It's equal to 1. Stay with me, everybody. Everybody. Some of you are drooping like lilies. Some of you are sleeping. Some of you are not. Get up. Get up from your chair and follow. Okay. Okay. So must be built to be equal to 1. Where the must is equal to the built is the 1. Can be built. On the right hand side, it will be 1. Can be built. Can be. What symbol is that? Notable.
X1 equals to 0.
X1 is equal to 0. That is not correct. Okay? Can be built. That is a possibility, but it's not correct. Can be built. Belinda?
It's less than or equal to 1.
Why?
Because it's either we are building or not. So if it's less than 1, it's 0. If it's maximum or the maximum part is 1.
Which is the maximum part?
The equal to 1.
Very good. 2 marks. Okay. So I wanted to be sure that you know exactly what you mean. So if it is less than or equal to 1, it means that the answers are either going to be 0 or 1. Why? Because we know that everything is 0 or 1. Anyway, everything is binary. And if this one is say can be built, so now we go to which variables are on the left to match what is on the right at the 1. Which variables are on the left based on the question? Belinda?
Swimming pool and tennis center.
How will you write it mathematically?
X1 plus X2 is less than or equal to 1.
Very good. So now this is how you got to formulate. Now, if the whole thing has been swimming pool and tennis must be built on the same piece of land, okay, because of that, only one of these 2 must be built. How would that have been? Only one of these must be built. How would that be? Benjamin?
X1 equal to 1 or X2 equal to 1.
No. Belinda?
X1 is less than or equal to 1, or X2 is less than or equal to 1.
Nope. Ben, you're learning from people's mistakes.
So X1 plus X2 shouldn't be equal to 1.
Shouldn't be equal to 1. Wrong. Stanley?
Doc, please, the question again.
Okay, so then it's going to be X1, X2, X3, and F4 will be less or equal to 0 or 1.
Wrong. Obada, sorry.
Okay.
Because swimming pool and table tennis must be built on the same piece of land, only one of these must be built.
X1 plus X2 is equal to 1.
It is. So it's supposed to be X1 plus X2 equal to 1. If you are not paying attention, we finish this thing and you realize it was just that you weren't yet paying. So the can changes to must, which means the less or equal to must change to equal to. There's no mark for that. The question went around too much. It makes people learn. So such question and its answer becomes a learning thing. Yasin, you have a question?
Yes, please. So they can be built. The sign was less than or equal to 1, and then the reason was that because the answer can either be 0 or 1. But you see, less than or equal to 1, it means the answers can go into the negative. So are we saying the answers can either be 0 or 1 because we are dealing with binary?
You have already defined the decision variable to be either 0 or 1. You remember?
Yes.
So it can't go into negative.
Okay.
Non-negativity is applying here.
And then the other question I have is, when you say x1 plus x2 is equal to 1, I don't understand how that translates into either one swimming pool or tennis must be built. So please, can you explain?
So if I tell you that it must be built, it means that there must be equal to 1, right? It must be. If I say that, God, look, you must build that thing. You must. It must happen. It must happen means there is no two going around it. It has to happen. That is the one. It must be built means presence. It must not be built means absence. And presence is equal to 1.
Yes.
And besides, he was talking about the two of them anyway. He says because swimming pool and tennis must be built. So swimming pool is X1, tennis is X2. So is that. Now, that it means that one of them, what this must be built here means that one of them can be built, but not both of them. You agree with that?
Yes.
And that means that if one is 1, then the other must be what?
0.
But when you compare that with the one below, the less than or equal to, what the less than or equal to is that if one is 0, the other can be 1. But also if one is 0, the other can also be 0. That's what they say.
Okay.
So the one below gives you 2 options here, but the one above gives you only 1 option.
I think my main issue was with the fact that we are using plus, but I think it makes sense that if x1 is 1, the other one will definitely be 0. Thank you.
All right. Let's go on. There are other ones we look at. So all of those decisions become like this, and eventually we will now have a constraint like this. Now, I've looked at this, and we looked at a mutually exclusive constraint. And this is the one we just looked at, the must. The must is a multiple choice, it's forcing you to make a choice. Because you're going to build anyway. You can't say that, oh, I won't build it. You've got to build one of them. Okay, now, let's look at the non-negativity constraint. You've got to remember that, because sometimes if you don't take it, you forget the non-negativity constraint. Remember, this is either the construction or the non-construction of a recreational facility. So because it's binary, you got to indicate that it's equal to 0 or 1. That's an easy way to write a binary. Okay. But please note that when you write this binary like equal to 0 or 1, it's there. You got to also indicate the non-negativity constraint. So the non-negativity constraint must also be there. It must be part of it. Let's take a couple of other constraints that could have been said instead of this one. Yes, I've seen.
Please, why is it that for this one, the non-negativity is equal to 0 or 1? Because at the end of the day, we are going to build only like one
In
thing.
the non-negativity.
Okay.
That is a binary constraint. I'm only saying that the non-negativity is there. The non-negativity must be written in addition to this one.
Oh, okay.
I didn't write it, but you have to write. You have to write blah, 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 greater or equal to 0 before you add this. Or if you don't want to get confused, you can write x1, x2, x3, x4, greater or equal to 0, then add and binary. So when you do that and binary, what you're saying is that each one of them has the option of being there or not being there. Mamio Pele, do you understand?
Yes, please.
Any question? How would you formulate this constraint? Exactly 2 of the projects must be built. Exactly 2. Exactly 2 of the projects must be built. How will you write that? Philippa.
Yes, sir. Please, it's going to be the summation of all the projects being equal to 2, since 2 of the projects has to be built.
Write them.
Okay, that will be x1 plus x2 plus x3 plus x4 equal to 2.
Very good. 2 marks. Who doesn't understand? I had meant to give you 2 marks already. Yeah, Belinda.
So I don't understand.
2 marks woman. Explain it to her.
Okay, sir. So with the first example that Sir gave, with the example that we're actually working on, it's indicating that we are supposed to build just one, we are supposed to construct just one thing, but we have 2 that we are supposed to choose from. And we end up understanding that because of that, we would end up having equal to 2, making it a must that we should have 1 done. And with this example that Sir is given, is saying that we have 4 projects and we are supposed to do 2. We're supposed to choose to decide which 2 we are supposed to work with. And from the previous ones, he indicated that all of them is a probability. There's a probability that we can build any of them. So it should be that any of them will end up getting 2. And the formula for that will be the summation of all of them equal to 2, which is x1 plus x2 plus x3 plus x4 equal to 2. So be it any of them that we decide to choose, we'll end up still getting 2 projects done. Please, do you understand?
Not really.
Sir, please, can I attempt to explain it to her?
Because you fully understand.
Yes, I understand.
Good. Go ahead.
So we mentioned from the beginning that when we say must be is equal to, but with the first examples that we were talking about, the question said that either swimming pool or the tennis court must be built, which means that if you have 2 options, you can only choose one. So it's either you are doing A or you are doing B. So that's why for that one we do it equal to 1. So that's the x1 plus x2 is equal to 1, because out of the options you've been given, you can only build 1. But what this other question is saying is that we have 4 projects to build, but at the end of the day we want exactly 2, which means that out of all the 4 projects, by the time you are done like building, we should have 2 facilities we can see. And the options or the projects that you've been given is the x1, which is swimming pool, tennis, athletics, and gymnasium. It's equal to 2 because out of the 4 we want only 2 facilities, but that's up to the company or whoever is in charge to choose which 2 they'll build. Please, do you understand?
Belinda, you are the one who has
Yes.
the
Yes, but sir, but I want to ask a question. In that case, does it still hold as a binary equation?
Yeah. Remember, each of them can appear once or not appear at all. You see here, it says 4 of the projects, and we know the projects are 4. He could have said that exactly 2 of swimming pool, blah, 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 must be built. It's the same thing. It's still going to be X1, X2, X3, X4 equals to that. But let me just ask you something that will help you. The word exactly, what symbol is that? Belinda?
Equal to.
Equal to, so that's it. So when I say exactly 2, what is that?
Yeah, equal to 2.
So that's this.
Okay, I understood, but I think I was just thinking of the fact that it's equal to 2, and I'm thinking because we said it's between 0 and 1, it was just confusing us.
But what you shouldn't forget is that I also told you that that 0 and 1 is for each construction. Each. But here it's not each we are looking at, we are combining them.
Okay, that's fine. Thank you.
This one can appear is either 0 or 1. This one is either 0 or 1. This one is either 0 or 1. This one is either 0 or 1. So what we know is that at the end of the day, 2 of this must be what? Tell me.
Must be equal to 2.
No. You forget about it. At the end of the day, 2 of these.
Okay, must be constructed.
Yeah, which means that 2 of these must be equal to which number? Each one of them must be equal to which number?
Each one will be equal to 1.
And the other one, there's other 2. Each one of them 2 must also be equal to which number?
Must be equal to 1.
No. If they are all equal to 1, then the thing will be 4 now.
Okay, equal to 2.
No, you are confused. Yes, Mag.
I do.
I think each one of the others will be 0, and then each one of the others will be 1.
Yeah. And then this is a simple math. If I tell you that something is equal to 2 on the right-hand side, and you tell me that, oh, then on the left-hand side, there must be 10. No, it can't be 10. For it to be equal, okay, even if items on the left, only 2 of them must add up to 2. And that is what this one is saying. Let's move on. We have bigger things to look at. Next one. No more than 2 of the projects must be built. How will you write that? No more than 2 of the projects must be built. Remember, when we say project, we are talking about a combination of all of them. Keep that in mind. The combination of all of them, the addition of all of them, that's what we mean by the projects. One of my account projects, the mission, is a Hebrew. But we are not speaking Latin. Project here is the addition of all of them. What should this be? Kelvin?
Since it's no more than 2, it means it's supposed to be either 2 or less than 2.
What is it supposed to be? Mention the whole mathematics.
X1 plus X2 plus X3 plus X4 is less than or equal to 2.
Yeah, that's it. That's 1 mark. Let's go to the next one. When I say 1 mark, you should privately message the classroom. If swimming pool is very important and tennis is less important, what does this constraint mean? How will you mathematically write this constraint? What does it mean? And what about you say, I'll ask you another question about it. I will ask you another question about it. So declare what you're about to say before you do it. I hear it, okay?
Okay, Doc. It means that when they are choosing, swimming pool is a max. When they are choosing between swimming pool and tennis, swimming pool is a max. So since swimming pool is a max, we'll assume swimming pool will be greater than the tennis.
So how will you write it?
So we'll say S2 is less or equal to S2 is less or less or equal to X1.
That's wrong. You are copying. This is a clear indication to my brain power that you are picking a copy. No, because what you just said is that swimming pool must be greater. Then, but when you are now mentioning the thing, you now say that must be less or equal to. It doesn't tally.
No, Doc, I said swimming pool will be chosen over the tennis. So
Yeah,
meaning swimming pool is very important. Will be greater than
yeah, but when you
the
say
table
the
tennis.
swimming pool will be greater than, okay, and
Yes.
the word
Yes.
you have used, you should even use that same greater than symbol in your language. But you are not using the greater, you are using less than symbol in your language. Why will you speak greater than and then in the writing you write less than? Unless something is guiding your thought process. I'm smart. Don't underestimate my
No.
intelligence.
Okay, Doc, the reason why I use the less than is that I was watching the top constraint that we just spoke about. So I was actually using the same concept. You know, that's why I picked the less than. So you could see I was even fumbling because I was not too sure.
Okay, so it's less than what? What is less than what? So
Hey, Doc, why am I confused? So
that
I
is
was
the
saying swimming pool.
the confusion.
So Doc, let me put it in my own language. Swimming pool is greater or equal to S2. That is S1 is greater or equal to S2. I don't know if it is right.
Why is it greater or equal to? Why is it not just greater than?
Because they said it is very important. And this why it's less important. So it can either be or it can be the same, of the same value.
When will it be greater? If this is greater or equal to, when will it be greater? It's my subsidiary question today. That helps me to know that you understood what you said.
Okay.
If you tell me that something is less than, and I say, okay, when will it be greater than? You should be able to tell me. If you tell me that something is greater than, and I say, when will it be less than? You should be able to tell me. Okay, let's go to.
So it will be greater if the emphasis is on swimming pool alone. So if like the question said, out of swimming pool and tennis center, swimming pool must be built. That means swimming pool will be greater.
There's nothing here. There's nothing here that says that swimming pool must be built. Let's go to Ben.
So I was thinking it can be the other way around. Since they are asking you what does this constraint means, they are saying if swimming pool X1 is very important, what it means is X1 is greater than X2 or X2 is less than X1.
So this should be written as what?
X1 is greater than X2. Or you can also write it X2 is less than X1.
So it should be like this.
No. The equal to sign shouldn't be there. The greater or equal to shouldn't be there. Yes. Yes.
That's wrong. That's wrong. That's wrong too. Isaac.
Doc, can you say since the swimming pool is very important, can you say x1 is equals to 1 and the which one? The other one is optional. So can you say s2 is equal to 0 or 1?
It's not optional. It's not optional. I'm going to take the last one. We are delaying on this. Emanuela.
Okay, so I think it's x1 is greater than or equal to x2, sorry, because they are saying that the pool is very important. If they are of the same importance, then we are not going to have something to choose. So it has to be greater than or equal to the x2.
When is it only greater than them? See, that part is the real deal. Belinda.
So when it's not meant to be constructed. When x2 is not meant to be constructed.
You are still using the same language here. What would the language be for it to be greater than? That's my question. Maybe people are thinking beyond. Use the same language. Where would the language be? Sometimes one of you raise a hand, and the way the person raises a hand gives me confidence, that this person is coming to break the ice. Then when the person gives the answer, no, then I need to get water.
So the question again.
Mag, let me finish with you, Mag.
So when the very is attached to X1, I think that's when there's
Very
more
is attached
important.
to S1 here. The very is already attached to S1 here. If swimming pool is important and tennis is not important, if swimming pool is important and tennis is not important, that is this.
Okay, sir.
But if swimming pool is very important and tennis is less important, that word less important means tennis is also important, but swimming pool is important more than tennis is important, but they are all important. They are all being important is the equality part, but then the greater than part is the fact that this one is very important than that. Does that make sense? It's grammar. Elbrofo. Okay, let's move on.
Please, it's not clear.
It's not clear. Don't worry, we'll be clear. When we're about to close understand, we'll look at it. But the most important thing I want to focus on today is not that. Let's look at this one. So, by the way, this is it. Okay. And by the way, this one here, the one that she said here, who gave me this one? The last lady. Who was that?
It's Emanuela.
No, it wasn't Emanuela who gave me this answer. This answer was given to me by somebody. Was it Emanuela?
It was a guy.
Doc, it's me.
No.
You,
You were beating around the bush.
That was me.
What was your name?
My name is Emanuela.
I think then it's you. It's after the guy has gone round, and somebody has also made another mistake. Then you came in and polished this one. You are the one I'm giving this to. But then I asked you another question, which you couldn't answer, which was this greater than part, isn't it?
Yes, please.
Okay, then I'll make it to one now.
Okay.
Very good for confirming both of them. Yes, Obed, your hand is up.
Can I say x2 is greater than 0, x1 is less than 1, and x2 is strictly less than x1, sorry.
For which one?
For the one you just wrote on the screen.
The one I just wrote on the screen is the same one that is on the screen here.
Okay.
This one here is the same as x1 greater or equal to x2. It's the same thing.
Okay. Thank you.
All right. Now, what if they are both equally important? That would be equality. Okay. So that's this. This is a co-representation constraint. Right. So eventually, this becomes a complete model. This is complete model. Okay. Any question on this? Somebody says it doesn't understand. Don't worry. Well, we are going to apply it to the Tematextile Limited. You should be able to understand it from there. Now let's go to this one. And this one, we're not going to formulate the model. It is mixed integer. And mixed integer means that some of them are that, some of them are, non-negative, some of them are, potentially, some of them are binary, potentially, some of them are pure integers, some of them are not pure integers, and all of that. So I just wanted to look at the blue writings, and we'll conclude with this. Looking at the blue writings, Nancy is doing investment in building, land, and bonds. Which ones will have non-negativity constraints? Which one will, in addition, have integrality constraints, whether it's a pure or binary or mixed? Which one will be what? These three. Which one will help for what? So let's say that building is x1, land is x2, and bonds is x3. What restriction can you put on each one using your own knowledge? Using your own knowledge. First of all, we should know that Okay, I'll leave that because it's part of it. Otabo says you should not forget to write his name down. He's very keen on his maths. Okay, so who will be able to tell us the restriction? Forget about any writing. It's just the latter part. And it comes from what you know. Leo.
So building and land can take binary form, and then bonds can take integer.
No, there's nothing here that shows that it can take binary form. There's nothing, it has nothing to do with the previous one.
Okay, sorry. So building and land can be integers, and bonds can be I mean, it can take any value.
Bonds can take any value.
Yes, please.
No, you missed them. You missed them, but you were close. So land can be what? X2. It can be purely non-negative, isn't it? Because it can be decimals. Do you agree with that? You know, we can have a quarter plot of a land.
Okay, yes.
So you didn't cross your mind. That didn't cross your mind. But if that had crossed your mind, you would know that that X2 is the only restriction on it is a non-negativity constraint. But a building cannot be decimals. You cannot have, you know, a quarter building or a half building, you know, or 2.5 building.
Why?
Okay, why not? Why not? If you start thinking too deep, you think like my neighbor. You know,
Doc, because we have uncompleted buildings and we still call them building.
Yeah, but uncompleted buildings are not quarter buildings or half buildings. There is no calculation of them. Just as we have for land, you can clearly know that this is half plot. This is quarter plot of a land. But you can't say exactly the same thing for a building. You can't use the uncompletedness to define its quarterness or its halfness. Are you with me, Master? That's why I say don't start thinking too much.
Yes, Doc.
Yeah, because that uncompleted, there's a degree, multiple degrees of uncompletedness, which makes it very complex. So building will be a whole number. So X1 will surely be what? It will be greater than or equal to 0 and integer. So that one will be an integer. What about bonds? What about bonds? If you have worked with bonds before, you also know that it's the same as this. It's the same as the X1. Bonds too, you don't have decimals. You don't have decimals. The bond holder, the paper holding is a whole number. You can have two paper holding bonds. That's it. So sometimes one of the things you should notice that these things requires a bit of thinking to crack that code. I'm now ready to look at the substantive reason why we are here today. Yes, Yasin.
So, please, are you saying the bonds would have the same like constraints as the way the building was written?
Exactly.
Oh, okay.
It's a whole number. It's a positive whole number, just like that of the building, not the land. So let me show you the formulation. So when you look at it, okay, if you look at it here, this is the building and that of the bonds. Both of them are non-negative as usual, but you have an integer for them. But that of the building or that of the land is just non-negative, which means it can be decimals. It can be decimals. Okay, let's go to the fixed charge. Oh. I want to correct. Let's go to fixed charge. That is the problem of the day today. Now, ladies and gentlemen, the word fixed, who can give me another word for fixed? Another word for fixed. Ben.
Constant.
Constant. or Belinda?
So I was going to say constant.
Mercy. Mercy.
Say permanent.
Permanent. Deborah.
Unchanging.
Unchanging. Calvin.
Dog stable.
Stable. All right. So that's good. It's all good. Fixed. Constant. Now, in microeconomics theory, and pay attention, whatever you are doing, pay attention. If you don't pay attention from the beginning, the first 15 minutes, you get lost. So it's important you pay attention. Okay. Whatever you are doing that is worrying you there, stop. Stop. Have your pen and book and follow. In microeconomics theory, we define profit as equal to total revenue minus total cost. The total revenue is what times what? Manuela.
Price times quantity.
Price times the quantity. In our case here, we represent quantity by X. And then we subtract the total cost. The total cost itself is split into two things. What are they? And I know you've been doing economics, that's why. I was teaching economics for business before. That's why I'm asking you. Belinda.
Fixed cost and variable cost.
Good. So that in itself is the fixed cost plus the variable cost. Pay attention all. Now, what is the difference between the fixed cost and the variable cost? What is the difference between the fixed cost and the variable cost? Ibrahim.
Doc, fixed cost does not change when output changes, but variable cost changes with levels of output.
Very good. I'll give you 1 mark for that. Who can give me an example of a fixed cost? Practical one. Some of you, the names you are using, I don't even know the names, so I can't even call you. See, when your name is very strange on the thing, it makes it difficult for me to call you. Okay, so, Karen.
Rent.
Sorry?
Rent.
Rent, very good, very good, excellent. That's a 1 mark. Okay, give me another example. Another example of things that look like a fixed cost. Oh, better, sorry.
Salaries of permanent workers.
Sorry?
I said salaries of permanent workers.
Salaries of permanent workers. That's how you let's hold on to that one. It's an easy one that I want. Salaries of permanent. Yes, Comfort.
Utility.
Utility. Because we spoke about rent, you're also going utility. No. Utility, if you use more, you pay more. If you use less, you don't pay less. Sylvia, I want one last one.
Samuel.
Sorry? What did she say?
Taxes.
I haven't called you, Mercy. All right, okay, let's stop there. So you can talk about school fees. It doesn't matter what you do. As long as your school fees is paid, whether you pass or fail, you learn or not, okay, that money is being paid. Okay, that's a typical example of that. So this is a graph that shows the difference, okay? Fixed cost is fixed. Doesn't matter the level of production. Variable cost rises with the level of production. Keep that in mind. Because that principle is what we are going to use to understand the fixed charge. Pay attention with this story. The best way to explain fixed charge is to use a typical example to work out a fixed charge problem. Let's start. Tema Textiles Limited manufactures 3 types of clothing: X1, X2, X3. Pay attention. X1 is shirts, X2 is shorts. X3 is pants. The manufacturer of each type of clothing needs that the company has a suitable type of machinery available. Kofi, why is your hand up? The machinery needed to produce each type of clothing must be rented at the following rate. The shirt machinery is 200, short is 150, and pant is 100. So you have all of these things that are there. Manufacturing also requires that the amount of cloth and labor shown below. So before you can manufacture any clothing, you need amount of cloth and labor time. Each week, 150 hours of labor and 160 square yards of cloth are available. And below here, you have some items. So you have the items for the resources, and then you have the items for the revenue and cost. So what it means is that if you want to produce shirts, you need 3 hours of labor and 4 yards of cloth. And when you want to produce pants, you need 6 hours of labor and then 4 yards of cloth. The revenue or the price from shirt is 12 Ghana cedis. Okay. And the variable cost associated with that is 6. The first thing we've got to do is to define the decision variable. What would be the definition of the decision variable? Let X be what? Pay attention, please. Let X1 be what? Let X1 be what? Oh, somebody mentioned loan there, and that's true. X1, yeah, what? How will you define the decision variable? X1, Amanda.
X1 be equals the number of shirts that CTL has to produce, and then X2 equals the number of shorts TTL has to produce, and then X3 represents the number of panties that TTL has to produce to maximize profit.
What makes you use that unit of measurement? What makes you use that unit of measurement?
So please, number of shirts.
Yeah, what makes you use that unit of measurement?
So please, because these items are normally measured in quantities. That's why I'm using number. So yeah, we can have number of shirts. This can come in terms of bundles or dozens. That's why I just picked number.
Why not type of shirts?
Oh, okay. All right, so.
Huh? Why not type of shirts? Philippa.
Because TTL didn't specify the type of shirts they produce. All they said was they produce shirts, shorts, and pants. They didn't specify the type of shirts they produce.
Did they specify the number of shirts?
No, the type of shirt.
Did they specify the number of shirts? I agree with you. They didn't specify the type of shirt, but did they specify the number of shirts? Because she says it's number of shirts. I want to know why she's giving me that answer. I want to believe that answer is coming from her, or she's just picking it from somewhere and giving me the answer.
Okay, so I think the reason why she chose the number of shirts is...
Don't speak for her.
Okay, sir.
Don't you even go there and speak for her. She's sitting in her corner. She's hot, thinking about reasons, and has reasoning for her. Augustine.
Okay, so I believe we are using quantities. So if quantities, then probably we have to look at the number of shirts to produce.
Why are we not using types? Where did they mention quantities?
They are
No,
stated.
types
I
may
think
be brands or yes. So because shirt may have different types to be produced. But if you are going to use
numbers too. Don't worry, I'm only confusing you because I want to be sure the first speaker, actually knew what she was doing, but she's home. Okay? So the key point is still number of shirts produced because that was evident. It was evident from the entire story. If you go there, because what are you manufacturing? You don't manufacture pieces of items. You have numbers of items that you manufacture. Okay? And when it came to cloths, if you look at cloths, he used that same word, amount. So that's why I wanted you to pick your point from, that it is a number of shirts because there was an amount of cloth, an amount of labor. In the case of labor, it was labor hours. That was very specific. But it is actually the number of labor hours. And the amount is also the number of, and so therefore the shirt should be number of. That's what I wanted, the explanation. Okay, the second thing is that what kind of condition or limitation will you give to the shirt? Given all that we have done, what type of integrality constraints will you give to it? Remember, you said there were 3 types. What kind of integrality constraint will you give to the shirt? Belinda?
X1 is less than or equal to 0.
Yeah, but what I mean is that what type of integrality constraint? We have the names for them.
Okay, binary.
You're coming to list them all for me or what?
No.
Okay, so what type of integrality constraint are you giving? Binary?
Yes, please.
Okay. That's wrong. If it is binary, that's wrong. Mayor?
Sir, it should be integers.
What integers?
Sorry, I don't get your question.
Okay. Somebody gets it. I think Diane gets it. That's why her hand is up. Yes, Diane.
Is a mixed integer model?
No, it's not. Deborah?
The constraint will be
Not a constraint. I'm not talking about constraint. What limitation do you put on
the
this?
non-negativity and then the integer.
Yes. What integer? You didn't know that all these integers there were 3 types that we specifically spoke about them.
The positive one.
It's called pure integer. It is called pure integer. We mentioned it. We called it total or pure integer. That was the first one we mentioned. So you can have a binary integer and you can have a pure integer. Take note. A binary integer or pure integer. So this is a pure integer. Why? Because you can't have a quarter and a half of a shirt or 1/4 of anything else. Okay. Now, apart from this, there is another decision variable. Apart from the decision variable based on shirt, there is another decision variable. You got to make a decision on something. What do you also have to decide on? Ben?
But I think before you even start production, you need to get a machinery first.
Excellent.
That's the first thing you need to get.
For that, explain further. Explain further.
So before you even start production, before you even look at your labor or your cloth, the type of cloth you need to purchase, you first need to get a machine, because without a machine, you can't produce the shirt. You need a machine to produce the shirts.
You need the machine. So this is what a guy said, which I'm writing mathematically. If X1 or Xi, that is any of the items, is going to be positive or 0, let me put it positive rather. If I'm going to produce any of them, then that machinery, let's represent the machinery by Yi. That machinery must be what? Who can tell me? What will I write for the machinery? That machinery must be what? Yasin?
Equal to 1.
Equal to 1. Why?
because you actually need the machinery. With the question said that for each type of like clothing there is a suitable machinery available, and you can only use one machinery. You can't use more than one for each type of clothing.
Yeah, but what does the one here mean? Not yourself. What does the
It
one?
means that you actually have to have the machinery.
Yeah, but so you have to have the machinery. But I didn't want you to say that more than one will not be possible. It's not about the number of more than one. Get a point?
Okay. It means you can't have zero machinery.
Exactly. You can only have a machinery, not more than one machinery or more than two. You can have a machinery. And the one here indicates the presence of the machinery. The zero means the absence of the machinery. So what he said, what my good friend said, is that for the X to be positive, that is, for you to produce, to be available, to be there, then the Y must also be available, must be there. Therefore, we need to define the machinery type. So we should also let Y1 represent what? Who can tell me? Y1 will represent what? Matthew. Yasin.
Let Y1 be the machinery needed to produce shirts. Let Y2 be the machinery needed to produce shorts, and Y3 be the machinery needed to produce pants.
Yeah, but you have to give a condition. You can't just let the Y1 be machinery. Because remember that for you to even have Y1 there, then you already have in mind that you are going to what? Produce X1.
Mm-hmm.
So the presence of Y1 itself depends on whether or not you're going to produce X1.
Yeah.
So if I'm not going to produce X1, then I don't even need Y1. And if I don't need Y1, then I shouldn't write it as though it's going to be 1 all the time.
Okay.
So how will you
Can I put it again? Let Y1 be the machinery needed to produce X1. And I'm saying X1 because if we end up producing X1.
That one we understand. But there's a condition you got to bring there. Let's see whether your colleagues will crack it. Susie. Stanley, Mensa.
Sorry, I was unmuted once again.
Since your hand is up, your hand must be on the mute all the time. Remember,
sorry.
Let another person go. Be attentive for me, because there are a lot of hands there. Stanley.
Yes, no, it's a if. The condition should be if the machine is used to produce shirt. If the shirt is not produced, then there have to be a zero production.
Exactly. So Y1 should be 1 if X1 is being produced. That's it. And it should be 0 if X1 is what? Who can tell me? If X1 is what?
Less than or equal to 0.
That's wrong. Yasin.
Equal to 0.
Equal to 0. That's how it's supposed to be. It should be equal to 0. Pay attention, guys. Slight misappropriation of your mind, okay, it distracts you. So Y1 is a binary condition, and Y2 is a binary condition. But then the X's are integral, what do you call it? They are integer. They are integers, pure integers. Whereas these ones are binary integers. So take note. Okay, so Y1 is there. That is 1 if you are producing X1. That is X1 greater than 0. And Y1 is not there at all if you are not producing. That is if X1 is there. Write it down. Write it down. Write it down. Write it down. And then, of course, you have to do the same thing for Y2, the same thing for Y. Okay. So we've been able to define our decision variables. Some of them are X's, some of them are Y's. Now we are going to go into the Z function and formulate our objective function. Evans.
Okay, Doc, please, I want to find out if, as we have defined and represent Y1. I want to find out the moment you have decided to go and rent, meaning you want to produce, but will there be an instance whereby you go and rent without producing? Because I'm asking this because of the zero.
Okay. So you are asking that will you go and rent when you don't produce? Is that what you're saying?
Yes, Doc. Yes, Doc.
If you know you are not going to produce, you will not rent. That is why it is zero. That is it. If you remember, the last time we did a Farm Milk Ghana Limited thing, we had Fan Yogo and Fan Choco. We didn't talk about Fan Ice, but there was finance. But because we know that we are not going to actually produce finance, we will not talk about anything that is used to produce finance. We will not even talk about anything that is used to produce finance because we are not intending to produce finance. So it was implicitly zero. Oh yes, you will see that it happens. I mean, doesn't it happen that sometimes some companies will be having some product, but in a particular year, they say they will not do that product. Sometimes there are some courses you are choosing, but this academic year, they will say that, oh, we are not mounting this course. The course is there, but this time we are not mounting this course. So yes, there is a possibility of that thing being there or not being there. You get married, you want to give birth or you don't want to give birth. It's a possibility. There are so many things in life that are binary. It's a possibility. It's a possibility we can't ignore and make it look like the other one is not possible. It is possible that you will win the game. It's also possible that you will lose the game. Don't keep only the fact that I'm going to win there. It's possible that you will produce. It's possible that you will not produce. Don't keep the thing there. And if you are not going to produce, that will define whether you should get the machinery for it or not. Remember, this is a renter. So why would you rent? So you can choose that this year I'm not renting it because I'm not going to produce that thing. But next year, I'll rent it. Business people always talk about that thing. Oh, I feel anyway, but next year we'll do it. Okay, do you understand? Okay.
Yes, Doc.
Now, how will you formulate the objective function? Given the information. To formulate the objective function, it's the profit. The profit is the price times quantity. We have the price and we have the quantity. Who can walk me through the total revenue? Total revenue will be what? You have the information and the data set down here. Remember, the total revenue is price multiplying the decision variables, which is a quantity. So how will it look like? How will it look? Yes, Yasin.
So 12, so for the first one, 12x1 minus into brackets.
But you want to do the variable cost quickly.
I was going to do it like the way you've written it, so like total revenue minus total cost for the first one.
What you just wrote was for shirt. You need to add the rest right.
Okay. So 12x1 plus 8x2 plus 15x3.
So now that you have finished your total revenue for all of them, remember.
This is 15x2 is x3.
Yeah, continue.
Minus into brackets 4. No, okay, so 3 plus 2 plus 6.
Which one are you picking?
The labor.
Okay. Why are you picking the labor? Because that is a resource. Resource here means it's a constraint.
No, I'm supposed to pick. So I know I'm supposed to pick the variable cost plus the fixed cost, but my assumption was that the fixed cost is the labor plus the cloth.
But fixed cost cannot be labor plus cloth because
Yes,
we
now that you said
told about the rent as the fixed cost.
Yes.
That one is not here. Let somebody help you, Ben.
So we'll have 6x1 minus 6x1.
Why?
Okay, you have the minus already. So the variable cost here for shirt is 6. So we can have the fixed cost, which is the rent. So I wanted to do the variable cost, then I bring the rent.
That's fine. So you have 6 what?
X1 plus 4x2 plus 8x3. Then you can close this bracket and you open plus another bracket.
Oh,
It's supposed to be minus.
So you have one. So the total cost. So you have to get 2 brackets first. You open
I need to consider the minus.
Okay.
It's supposed to be minus.
So now we have the rent, which is we have 200 Y1 plus 150 X2. So I've forgotten the figures. Then plus 100 Y3.
Why?
Because that's what we defined as total fixed cost.
I mean, why 1?
So before we produce,
why not just write minus 200?
So the reason why 1 is because to produce shirts, we need the machinery for shirts, which is Y1. But we can do, okay, so says, okay, but the Y1 still means 1. The Y is just 1 machinery, so we can still leave it out.
I like the way you are battling it. I'm only asking you to think, that's all. Because when you write why 1?
Because we need 1 machinery to produce the shirt.
Rental. Is a rental.
Rental.
So
Okay.
Y1 is just rental of the shirt machinery.
Okay.
You cannot have the cost, which is a 200, unless you are renting the shirt machinery. Don't connect it to the shirt. It's a rental of the shirt machinery. So if I am renting the shirt machinery, which is Y1, then I will now incur this 200, which is the cost of it. Now, Y1 will just take a value of 1. So if it is 1, then I actually rented it because now we are left with the 200. But if it is 0, Y1 takes a value of 0. Then it means I've multiplied it 0 by the 200. I'll get everything here to be what? 0. So Y1 is just the presence or absence. It doesn't spoil anything in the equation. It is just a presence. If it is a present thing, then it is 1. Then we are back to the 200 cost. If it is not, and it is 0, then we didn't even do anything with it. And now that this Y1 is 0, if Y1 here is 0, then we expect X12 to do what?
0.
Let's see. Mercy.
Sir, please, I don't.
You are muted again.
Sir, please, my machine is misbehaving. Please, I said I don't understand the minus. The minus that came before the 200Y plus. I thought it's supposed to be plus because we are.
And there is it comes from here. It's minus total cost. The total cost itself is 2 things. It's the variable cost and then the fixed cost. And all of them are minus.
So, sir, please, I thought this minus, I understand this minus, but I'm talking about the variable cost. It's supposed to be variable cost plus fixed cost. Because it's in brackets, the minus will affect the whole bracket.
Yeah, but remember that I didn't put the whole bracket. The guy told me to split them. So you can see that there's here.
Okay, sir.
Yeah.
Thank you.
All right. So anyway, so now you can group items. So when you group items, this 12 and this 6 will simplify each other. The 8 and the 4 will simplify. The 15 and 8 will simplify. So our final equation is going to be, when they simplify, the first one will be what? Anybody? Augustine? The first one, Evans.
Yes, sir. No, please. The first one will be X12. 12X1
No, it won't be 12x1. Just give me the answers.
Because we are minusing
No, just give
12
me the answers. We are
minus
grouping
6. So
items.
when we group the like terms,
Give me the
when we
answer.
group the like terms, okay.
Let somebody help you. Belinda.
The answer will be
6x1
You get 6x1
plus 4x2
plus 4x2
plus 7x3.
plus 7x3. When you group like terms, this whole thing will go and it will be left with this. Because it's 12 minus 6. 12 minus 6, 8 minus 4, 15 minus. I went through that, so I wanted just the answers. And then you will now add your other ones, minus 200, y1, minus 150, y2, minus 100, y3. Evans, do you follow?
Sure.
Yes.
You asked the question earlier. You were asking if y1 is equal to 0, what happens to x1?
Yeah.
Well, x1 will be 0, 2.
Yes, that's true. And you wanted to answer?
Yes, sir.
Hey, yeah. Oh, Mark.
Doc, please, I have a question.
Right.
Please, the one in red, I realized that, no, the writing, you did, for the y3, you just did plus y3, so I was a bit confused. But in the next one, you did it plus 100 y3. So is it that the first one was like an error?
Oh, it was a typo. It was an error, yeah.
Okay, thank you.
But eventually, you're going to get to this. We know that there are 200, 150, and then 100. So the objective function is now completed. This is objective function. Any question on the objective function? Evans, your hand keeps coming up. I don't know why. Are you there? All
no,
right.
it was a mistake. My kids were interrupting, so I have to.
So we go to the first constraint. Okay. Now, if you could remember the constraints, let's just go back here. First constraint, just use the table here. Who can formulate the first constraint, the labor constraint? So coming back to you, Yasmin, the first constraint is labor, the second constraint is plot. Who can formulate the first constraint for us? And the availables were given. Okay. So keep that in mind when you're talking. Augustine.
So I'm asking the objective function that you have raised, you didn't add the mass to it. So I don't know whether we are still maximizing or we can just write the
You see it later on in the function itself. You see it later on in the function. This was just to break down certain. We've not come to the point of maximizing and then all of that. This one is just breaking things down first. Philippa, go ahead.
Thank you.
Okay, sir. So for the labor constraint, I believe it's going to be 3x1 plus 2x2 plus 6x3 less than or equal to 150.
All right. Continue with the cloth.
And then for the cloth constraints, it's going to be 4x1 plus 3x2 plus 4x3 less than or equal to 160.
Very good. 2 marks for that. At least you are following. You are following. So that is it. Okay. If you are a bit lost, you can ask. So that is how you formulate the 2 constraints. But I'm going to show you something. Pay attention. At this stage where we are now, some people may have switched off. Don't switch off. Don't switch off. Okay. Now let me put, so this was a constraint that you put there. This is a constraint that she just mentioned. Now at this stage, there are 2 more constraints to include, given what we have done so far, given the understanding we have about the X and the Y. Who can give us the next constraint? Who can give us the next constraint? Matthew.
Sir, please, x1, comma x2, x3 are greater than or equal to 0, and an integer.
Excellent, beautiful. And integer. But that's not all, oh, share. You can give us another constraint.
Sir, please, can I continue?
Continue.
Since we are introducing the fixed cost variable, we'd need to put the constraint since x1 and the
Continue.
fixed cost.
They all understand what you're saying.
Okay, so y1, y2, and y3 are equal to 0. Or 1 because it's dependent on if we are to produce.
Very good. What constraint is that? What constraint is that?
It's a binary constraint.
Binary. Very good. So these are the last two constraints that should be incorporated to have your work complete. But the question is it complete? Let's look at this. So this is it. What is a problem here? What is this is a fantastic. So by the way, you can see that your max here is there. Okay? Your maximization when you are fighting is here now. What is a problem with this formulation? Look at it carefully. Compare the objective function with the constraints. What is the problem here? What is the problem, Belinda?
The maximization function has y variables, whilst the rest don't.
Why?
Because the labor constraints and the plot constraints. So in fact, I don't know why. I can't explain.
If you don't know why, that beautiful answer you gave came from somewhere you took it.
Yes, I was going to say the labor constraint and the cloth constraints don't have anything to do with the machine, but that's wrong. I'm not too sure.
So part of the reason why sometimes I don't give notes to students is because when they look at the note, it makes them feel that they can give an answer by looking at the answers in the note. And so they don't think beyond the surface. So sometimes I don't give it to them earlier so that they will open up, they will stretch their mind. Matthew.
Doc, following up on what Belinda said, the constraints don't have the y variables or the y variables. So there's no way to link it between the constraints and the objective function. Sorry.
Why? Okay. So here's the thing. Anytime you are formulating a linear programming situation or any formulation, there must be a situation where whatever you are trying to find, whether it is X or it is Y, they are both in the objective function and the constraint. Why? The reason is because it is subject to it. Whatever is up there is subject to what is down there. It's subject to. And if it is subject to, then it must contain the same elements that it has here. So the entire body of constraints, the variables there must be in the entire body of the objective function, the variables there. But this one doesn't. In fact, if you solve this one, this is the result you get. What is the problem with this result? If you solve it in Excel, this is the result you will get. What is the problem with this result? You can give me specific examples. Specific, not general examples. So pick specific examples and tell me. Belinda.
So the result is saying that y1, y2, y3 are equal to 0. And if there are no machines, then that means you can't produce any of the shirts, the shorts, and the pants. But then there are values. We have values here for x1 and x3, which is the shirt and the pants.
So
it's not possible. I don't know.
Why is it not possible?
Because we've not rented machines, so how were we able to produce the shirt and the pants?
Excellent. 2 marks. That's it. At least I'm pushing you to think, and you're thinking. Okay? I don't want you to take it on the surface, but I want you to be able to question the surroundings. Question your surroundings. Question your surroundings. Because if you say that you are rented these machines, then you can now produce these clothes. But you've not rented any machine, and now you are producing clothes, so it doesn't make sense. So that is it. Excellent. Now, we need to now introduce something which is known as linking constraint. There is a standard linking constraint. I want you to write this down. The linking constraint is given by xi less than or equal to mi yi. So for x1, it should be less than or equal to m1 y1. For x2, it should be less than or equal to m1 m2 y2, and then on and on. Why the need for this linking constraint? But what is even m1? Now, guys, follow me here because this is deep. This is deep. Sometimes you can switch up in this thing, especially when you don't understand. What are the values y1 can take? Who can tell me? What are the values y1 can take? What are the possible values y1 can take? Mad?
Values greater than 1.
No.
1 or above.
No. Ben.
0 or 1.
0 or 1. These are the only 2 values. Write it down. You see, the challenge with most of these are you don't write things down. That's the challenge. You should. So if y1, listen carefully, if y1 is 0, what is going to be on the left-hand side? Sorry, what is going to be on this right-hand side? If y1 is 0, what is on the right-hand side? If y1 is 0? Kofi?
The rate of y1.
No. If y1 is 0, what will be on the right-hand side? Matthew?
0.
0. Okay. So it means that x1 will be 0. That's what it means. Because if y1 is 0, you multiply 0 by m1, everything is 0. Now, if y1 is 1, listen carefully. If y1 is 1, then x1 is equal to what? If y1 is 1, then x1 is equal to what, Belinda?
X1 is greater than or equal to 1.
It says x1 is greater than or equal to 1. No.
Oh, sorry. X1 is less than or equal to 1.
I said if y1 is 1, x1 is equal to what? That was my question. Mayor.
So x1 will be equal to m1.
Very good. Now watch this. And x1 will be less than what? X1 will be less than what? If I don't break this thing down like this, you understand. Belinda?
0.
No. X1 will be less than what? Emanuela?
1.
M1.
M1. Very good. Pay attention. Pay attention, everybody. Pay attention. It's just breaking down the same thing. So it means that x1 can have some values that are less than m1. Pay attention. x1. It can have some values less than m1. And this same x1 can also have some values that are equal to m1. So actually, x1 can be m1, which means that m1 happens to be one of the x's. But actually, m1 is the highest value that x1 can take. Write that down. m1 is the highest value that x1 can take. There are other values of x1 that are going to be less than m1. But the value of x1 that will be equal to m1 is the m1 we are talking about. So the definition of m1 is the upper bound of x1. Write it down. The definition of m1 here is the upper bound. So M1 is nothing more than X1. But the thing is that there are so many of the possible X1s. The highest of all will be the M1. But I would note that the highest of all, that will be the M1, must satisfy all the constraints. The highest of all is the M1, but it must satisfy all the constraints. With this mindset, we are going to find M1 in this model. Because you see, this equation you are seeing here, this is a linking constraint. This is the equation that actually links the objective function with y to the constraint that has no y. So once we are able to get this value, let's say we get the value to be 10, then x1 is going to be less than or equal to 10 y1. So now we know the connection between x1 and y1, and that connection is through 10. So now we've got a link. How do you find the M1? That is the real deal in fixed charge, but it's very easy to do it. So we're about to start to find M1. Please pay attention once we go through.
A question.
Yeah, go ahead.
Please, can you go back to where you wrote on the screen? I wanted to know why the first one you separated it. You did M1 is equal to X1 is equal to M1, and then X1 is less than M1. Why did you?
I said that because I wanted you to know that if Y1 is 1, there are possible values that M1 can take. Do you agree with that?
Yes.
And those possible values that M1 can take actually happens to be the X's. You know, it's like when you are doing mean, okay? When you have normal distribution curve like this, then the mean is the center. And then, but everything here is also the X variable. So the mean happens to be one of the X variables. So when I say mean happens to be one of the X's. It's not a strange number. It just happens to be one of the X's, but just that it's in the center. So I'm just saying that this M1 value, this M1 is the highest value that X1 can take. That is the equality part. But anything else which is below this M1 is also an X1 variable, but is below. It's an S1 number, but it's below. So it is one of the X1s. That's what I'm saying. And the only way for you to know that it's one of the S1s is I need to do this and do that for you to know that this one is when the values are below, and this one is when the values are equal to. The equal to one is the one we are looking for, not the below ones.
Okay. Thank you.
Remember, normally when we are finding the constraint, we set it to equal to, and then find if y is 1, what is x? If x is 1, what is y? Take the equality sum. So, on the basis of this, we are going to find M1. When I finish finding the M1, I'll let you find M2, and I'll let you find M3. How do you find M1? Remember, the equation says x1 is less than or equal to M1, y1. To find M1, you got to assume, watch it carefully. Remember, M1 is one of the x's. So you got to assume that x2 is 0 and x3 is also 0. That's what we got to assume in the constraint. Because we want the thing to appear in the constraint. So we are going to touch the constraint. So looking at the constraint, look at the constraint, look at the constraint. We are going to take each constraint one by one and set x2 and x3, which we don't want. We are dealing with x1. Set them to 0. And then set the whole equation to equality because we want the maximum. And find x1. So if you set this one to 0, because x2 is 0. If you set this one to 0, because x3 is 0, we are left with 3x1 equal to 150. What is x1? Belinda?
50.
So x1 here is going to be 50. That's what I label. Go to the cloth. What is x1 in the cloth? Raise your hand. What is x1 in the cloth constraint? Manuela.
40.
X1 is 40. So we got the two numbers. One of them is the M1. Which one? One of them is the M1. Which one? The first answer that came to your head is wrong. So think again. Matthew.
Hey, Doc, please, I think it's 50.
I said the first answer that came to your head is wrong. Then he said that. For you to be able to get the right answer, you need to put the two of them, the 50 and the 40, into the constraint and see which one makes the constraint binding. You should not flout. You should not. Which one is feasible? It is feasible when it is equal to or is less than. So let's start. Let's start with the 50. You put the 50 here, you get 150, which is equal to the 150 here. So that's fine. But you put the 50 here. Remember the others are 0. You put the 50 here, it will be 4 times 50, which is 200. Is that binding?
No.
No. 200 is here, it's not less than 160. And it's not equal to 160. So that is wrong. Now take the 40. You put the 40 here, it will be 120. 3 times 40 is 120. Is that binding? I mean, is that feasible?
Yes.
Yes, it's feasible. It fits because it's less than 150. You put the 40 here too, you get 160, which happens to be equal to this 160. Is that feasible? Yes, it's feasible. So 40 satisfies the two constraints. Therefore, M1 equal to 40. So for the first linking constraint, this one up here, we are going to rather write it as X1 less than or equal to
40.
It's not less than or equal to 40. It's 40 something. Evans.
40 Y1.
40 Y1. That's it. So that is a linking constraint for the first one. Now you're going to use this same thing for X2 less than or equal to M2 Y2. And tell me the value of M2. Go through it. Go through it.
I have a question about the X1.
Go ahead.
So the final answer, which is X1, is less than or equal to 40 Y1. Does this mean that you get X1 if you have 40 of the Y1 machinery? Like, is that the interpretation?
No. What it means is that if you are ever able to buy the shirt machinery, which is Y1, that means Y1 is going to be 1. If you should ever rent the shirt machinery, then it means that the maximum value that X1 you can produce for X1, the maximum you can produce is 40. So if you should get it, you are going to produce a maximum of 40. If you like that 40, then go ahead and buy that, rent that machine.
Okay. Thanks.
All right. Sometimes you don't like it. You look at the maximum.
So what does the sign mean too? Like, I understand that if you buy the machinery, the maximum you can produce is 40. But then the sign less than or equal to.
The sign less than, the maximum I spoke about is equal to part. The maximum is equal to part. The less than means that you may, even though you have the maximum, you may not produce the maximum. Because of some potential negligence, if you don't take care, you may not produce the maximum you are supposed to produce. So you may produce 30, you may produce 35, you may produce 40, but ideally the maximum you should produce is 40.
Okay, thank you.
And you should go for the maximum, of course. You should go for the maximum. Because you are in a perfectly competitive market. And you can't affect the price. The price is fixed. So you just, to raise money, to get more revenue, you just have to produce more. increase the quantity of production. So you can produce as much as you want. But this one actually limits you with even as much as you can. Because there are some companies, they overwork the workers. And then by the time you realize, they start getting stressed and start dying. So that is not proper. That's why there's a limit to what they should produce, maximum. So sometimes overtime is good, but overtime is bad. Who has found M2? Going through the principle. I'll ask you some few questions first. Deborah, what two values did you get?
75 and 53.33.
And which one did you use?
53.33.
You had 75, right?
Yes.
Okay, yes, that's correct. So the M2 is actually 53.33, or approximately 53. You got 2 marks, Deborah. Guys, yebi. When you are here and you may not fully get everything, but when it comes to working it like this, do some. Remember that for the X2, you have to assume that the X1 and the X3 are 0. And for the X3, you have to assume that the X2 and the X1 are also 0. So who is done with the X3? Utabe.
25 and 14.
Which one did you choose?
25.
Excellent. 2 marks for you as well. Okay. So that is how you got to execute this. So let me show you all of these. If you work it well, everything I've done here, this is what you get. I've just rendered the M2, but it's okay. So this, you now have to put all of them back into the equation. After you've gone through all of these, you have to put them back into the equation. And now you get finally this complete model. Guys, what you just did is 25 marks. What you just did is 25 marks. 25 marks. There is no Excel. There is no further question. You just formulate, you get 25 marks. This is it. Now, for you to be able to do this well, you have to work more examples. Let me tell you possible things that can change. The constraints here are just 2. The constraint can increase to 4 or 5. It doesn't matter. All you have to do is that if you assume that X2, X3, X4, X5 are 0, you find X1 in each constraint. After that, you select the smaller one that satisfies all the constraints. And then you come to the next one, X2. You assume that X1, X3, X4, X5 are 0. And you find X2 in all of them. After that, you find the one that satisfies all constraints. Evans, your hand is up.
Yes, Doc, please, I want to ask that is there an instance whereby after solving, all the 2 will satisfy the constraint?
Yes. You will get a satisfaction. No problem. You will get a satisfaction. Stanley.
Yes, Doc. My point is about the once we get a decimal, for instance, the X2 where you had 53 points decimals. If the decimal is maybe 53.7 and you run it up to 54, is it cool, or we should only take the 53 and leave the decimal?
It's fine. If you round it, it's fine.
Okay, thank you.
So there's a couple of questions there in the slide that you should check. But by the way, when you solve this one in Excel, this is a result you get. This is a result. Who can tell me why this results make sense than the previous one? Benjamin.
Yeah, because y3 is equal to 1, which means we rented the machine and we got the production of the x3 value.
Amanda.
Yeah, because we rented the machine for shorts and we're able to produce the maximum of 25 short pants. The maximum benefit.
So this optimal solution makes sense because x3 is equal to 1, which means that x3 is present, which means that the machinery for x3 is present. So then we were able to produce x3, which gave us 24 in total.
Excellent. Excellent. That's it. So normally when you have done your formulation, that's it. This is 25
No, Max.
over 25. Any question?
0.5 mark.
Oh, this question, everybody was breaking it into pieces. Was it the last person who was rather telling me that, Max? Or the first person?
No, the last person.
Oh, but the last person, you can't just leverage on what others have said and demand Max. Because they spoke and spoke and spoke. And you came to just round it up.
Oh, so I didn't leverage on it. I just knew as soon as I saw it.
And everybody has been answering. So it means that.
And so I've been writing notes, so I know what it was as soon as I saw it.
And then you don't have a problem. So all those other people who gave the answers, how many were there? How many were there? Benjamin.
I think
2 in addition.
The Benjamin and I think one of that person.
Belinda.
Benjamin and who?
Belinda.
Right.
And then Angela. Is that it? Or Angela?
Yes, please.
Okay. So 2 marks for all of them.
Thank you, Doc.